Good afternoon and welcome to session 3 of the 2020 Forest Growers Conference. The conference this year, presented as a series of webinars, is the once-a-year opportunity for you as participants in the industry to update your knowledge and understanding of the Forest Growers Research Program over the past 12 months. For those of you in attendance with other demands on your time, you will appreciate the efficiency of the webinar format. So if you know of anyone who may not be here today, this session is repeated on day 2. And I believe registration is still open. My name is John Schreider and I currently represent small growers through the New Zealand Farm Forestry Association on the Forest Research Committee. The session this afternoon is entitled Online Tools and Other Species Updates and has been designed to be of particular interest to small forest growers. Those of you seeking to understand what tools are available to assist you in maximising returns from your forest investment, as well as update progress with work on realising the potential of other species, will find these presentations of interest. We also know that corporate and larger privately funded forest growers are continually exploring options for greater commercialisation of species other than radiata, and this to a large degree is driven by the need to consider risk of climate change effects as well as mounting social licence pressures, notwithstanding the need to be economically viable. We will get a sense of the scope, scale and direction of this work over the next hour or so. First up we have Glenn Murphy, who will demonstrate the use of his recently developed woodlot analysis tool, WATS. Many of you will know Glenn and be familiar with his contribution to forest research over a long period of time. His specialty is forest harvesting and harvest systems, and the WATS web-based tool enables users to input their own forest description data to provide indicative costs and returns. This will be followed by a presentation by Sawn's Melissa Evans, who will demonstrate use of the forecast calculator. This is one of several tools available primarily for the small woodlot owner trying to understand the volume and product mix of a forest stand nearing harvest age. Output from the calculator provides high-level data to enable better informed discussion and negotiation when the woodlot owner is communicating with harvest providers. Following the online tool demonstrations, we have 5 presentations on some of the more common other species that potentially offer alternative forest revenue streams. The Specialty Wood Products Research Partnership between government and industry seeks to develop a high-value specialty wood products industry based on alternatives to radiata pine, and we will hear about progress since the program initiation in 2015 from our lineup of speakers. Natural exotic forest description data suggests there is around 10,000 hectares of cypresses in New Zealand. I note some of the earliest plantings date back to the 1860s, but note also around 70% of the resource to be up to 20 years old. So there is recent developing interest, and here to tell us about this is Scion's Toby Stovall. Next up we have Paul Millen of Vineyard Timbers Limited, who will update us on the continuing work on the durable eucalypts. Paul, of course, has been the main driving force of the New Zealand Dryland Forests Initiative over the past 10 to 15 years, and that work is concentrated on 3 principal species for genetic improvement, species I won't try and pronounce due to my inherent difficulties with the Australian language. Tony Stovall will then return after catching his breath to cover the non-durable species of eucalypts, namely nitens, fastigata and regnans. Some of us will be familiar with the rather mixed successes of larger scale commercial eucalypt plantings in the 1990s, predominantly for pulpwood production. However, this program is aimed more towards breeding for growth, form and wood density for solid wood products. Commercial plantings of redwoods have occurred since the early 2000s, and it is interesting to observe the performance of this species as you drive some of our country roads. Simon Rapley of the New Zealand Redwood Company will share some of his wisdom and update of work since a previous presentation, I believe was 2 years ago, at the Tauranga Forest Growers Research Conference. Finally, this afternoon we have Ian McIver of Plant and Food Research, who manages the poplar and willow breeding program for the New Zealand Poplar and Willow Research Trust. We generally understand the benefits of willows and poplars for erosion control and stock shade and shelter, and with increasing scrutiny of our land use social licence, this work is timely as we hear more and more about compulsion around such things as farm plans and tightening water controls. Hopefully more planting of these versatile species will become increasingly important in our land use decision making. Can I please ask that you submit your questions as we work our way through the presentations? At the conclusion of Ian's presentation, we will then proceed to 20 minutes of live Q&A. So here to get us started is Glenn Murphy.
Hi, my name is Glenn Murphy. Today we are going to look at some of the features of Watts, which was developed by myself in collaboration with Dr. Reen Visser from the University of Canterbury. Watts was designed and built with the help of funding from Forest Growers Research Limited. Its target audience is small forest growers. They can easily use Watts to determine the net revenue that might be obtained from harvesting their woodlot. Watts can also be used to determine how sensitive net revenue is to some key variables. Watts provides semi-specific costs and returns from harvesting a woodlot located in New Zealand and described by the woodlot owner. It is web-based and located on the Forest Growers Researchers website under the Calculators section. It's designed to run on desktop and mobile platforms such as tablets and smartphones. It's compatible with Google Chrome, Mozilla Firefox, Microsoft Edge, and Safari web browsers, but it's not compatible with the legacy Internet Explorer browser. Let's step our way through Watts now using a woodlot located in the Bay of Plenty. The address for the woodlot is 1188 Manawahey Road. We're going to call it Demo. It's located in the central North Island. It has an area of 31 hectares, and the distance from the public road to the edge of the woodlot is 420 metres. A new access road doesn't have to be built to the edge of the woodlot, and the terrain is fairly easy. It's about 4/5 or about 80% flat and 1/5 or about 20% moderate. Pre-harvest inventory assessment had already been carried out for this woodlot. There were 2 grades of pruned domestic saw logs, 4 grades of export logs, and 1 grade of domestic pulp logs. And the information that was available was the expected yield in tonnes per hectare for each of the different grades of logs, and the price in dollars per tonne for each of those grades of logs. Let's get started. We go to the FGR website and click on the Calculators button at the top of the screen, and then we click on the Woodlot Analysis Tool button. First taken to an instructions page. This is followed by a woodlot location page, a woodlot details page, a log grade and yield page, a costs page, and a woodlot summary page. There is also a handy JAS to tonne price conversion tool. The instructions page suggests that you have available the woodlot details and yield data that I've just described. It also suggests that you read the Watts User's Guide, which is located above the instructions page. Now click on the Start button. The location page is where you use a Google Maps interface to locate the access point to your woodlot. It must be on a public road. We type in the address for the woodlot. In this demonstration, it is 1188 Manawahey Road. We zoom in or out as needed. And then drag the red pin to the access point. Now click on the Woodlot Details button. On the details page, we provide a description of the woodlot. We first enter a name. We next select the zone in which the woodlot is located. New Zealand is split into 7 zones. The zone information is linked to indicative harvesting, roading and planning cost data. We select Central North Island. Next we enter the net stocked woodlot area. Then the distance from the public road access point to the edge of the woodlot. Then we select if a new access road has to be constructed. And then finally, for this page, we describe the terrain mix in terms of fifths. Now we move on to the logs page. On the logs page, we will be entering information about the log grades that are likely to be harvested from the woodlot. This includes the expected yields and the expected wharf gate or mill gate prices for the logs. In our demonstration woodlot, this information came from a pre-harvest inventory assessment. If an assessment has not been carried out, one of the growth and yield calculators on the FGR website could be used to obtain the yield information. There are also a number of New Zealand websites that provide recent log price data. Log grades are selected from a drop-down list. After these have been selected, we will enter expected yields. These will be followed by expected prices. Gross return for each log grade is calculated for the whole woodlot and is shown in the right-hand column. Total volume expected from harvesting the woodlot and total gross returns is shown at the bottom of the page. We can now move on to look at the costs page. All costs shown are calculated automatically based on earlier user inputs. Costs are calculated for planning the woodlot harvesting operation, construction and maintenance of roads and landings, transporting machinery onto the site, harvesting the woodlot, cartage of wood to mill and ports, a harvest management fee, and other costs such as weighbridge fees, clean-up costs, etc. The user can override individual calculated costs if she has better information. From the cost page, we move to the summary page. Here we have a summary of total gross returns, total costs, and net returns from harvesting the woodlot. Net returns are also expressed on a per hectare and per tonne basis. A pessimistic to optimistic range in net returns is also provided. These are based on the assumptions that log prices could be up or down by 5% and costs up or down by 15%. The print button provides another on-screen summary of the inputs to and outputs from Watts. It also allows the user to select printer settings such as printing on a physical printer or printing to a saved PDF file. If you don't want a physical or digital print output, just click on the Cancel button. Now that we've finished analysing the demo woodlot, we can either leave Watts or we can click on the Reset button if we want to analyse potential net returns from another woodlot. The Reset button clears all data and takes us back to the instructions page. Now let me quickly show you how Watts can be used to answer what-if questions. The expected net revenue from the demo woodlot was $72,717 per hectare. What if the harvest was delayed by 2 years with the expectation that export log prices will go up by 5%? The trees would continue to grow at a rate of about 28 tonnes per hectare per year. Our log grade yields would go up, and so would the prices for the export log grades, but not the domestic log grades. If we had not clicked on the reset button, all we would have needed to do was step back to the logs page and enter the new yields and new prices. Gross returns, costs, and net returns would all be immediately updated, and we would find that the expected net return from delaying the harvest by 2 years would be $81,247 per hectare, or an increase of about $8,530 per hectare. That was a quick overview of some of the features of WATS, how it can be used to analyse net returns from woodlots, and how it can be used to carry out sensitivity of net returns to some key variables. A companion tool to WATS is the book that Reen Visser and I wrote on how to market and harvest your forest woodlot for profit. As well as a source of useful information, it also provides 2 more case studies on how to use WATS. The book is also freely available on the FGR website. Thank you for watching this video on the woodlot analysis tool WATS.
The time to stop runaway global warming is running out. Fast-growing forest trees are the most effective way at this time for us to fight climate change. They suck carbon from the atmosphere. That's a big environment plus, and there's more jobs and income if you grow trees than farming sheep and beef. That's why so many smart farmers are so bullish, planting out trees and loving our forests.
Hi everyone, my name is Melissa Evans and I'm the Science Leader for the Forest Informatics team here at Sawn. And today I'm going to be going through the aims and benefits of the Forecaster Calculator, plus give you a quick fly-through demo of the calculator itself. Let's get started. The Forecaster Calculator was a co-funded project between Forest Growers Research and Sawn, and it was started in 2016 and fully deployed in 2018. It was created for two purposes: A, to provide a woodlot and small forest owners with an accessible calculator that can provide a rough estimate of volume and log product mix on a particular site at a particular age. And B, to answer a problem around the current use of the Excel spreadsheets, the calculators, not knowing who was using them and what version they were using. Additionally, the manual distribution of the spreadsheets were cumbersome, and there was a dependency on the operator having access to Excel. Therefore, using the web as a delivery platform was the best option to solve version control and accessibility to the calculators. Plus, we want to provide a tool that was simple to use and intuitive. Some of the key things you'll need on hand when running the calculator will be the location of your woodlot, the planting age, and any silviculture events such as pruning, thinning, or measurements completed. I will demo these areas of the tool later in this talk. You have the option to navigate to your woodlot via the map, which automatically updates with the site index and 300 index for Pinus radiata. If you have a Douglas fir woodlot, then you'll need to add that in manually. The expected outputs you will receive after each simulation run, and they are delivered as PDFs, are the log yield report, the crop condition report, and the silviculture details report. I will run through these a little more detail in the demo. There's a fourth output, which is the annual crop condition CSV file. The key benefits of the Forecaster Calculator are that it's online delivery. It's accessible anywhere, anytime. The calculator is hosted with Integral, who provide the Atlas Forestry solutions, and they will provide you with any support you need. It is device independent as it is browser-based and accessible via tablet, laptop, and desktop. It is consistent with the expert version of Forecaster. The back end of this online tool is connected via a mirrored version of the expert version of Forecaster, which is hosted in the cloud. Therefore, the calculator is using the same data, models, and surface layers located within the expert version of Forecaster. Forecaster Calculator is a simplified version of the expert version and a quick way to run a single simulation for your woodlot. It is a simple calculator and does not have the full range of the expert version of Forecaster, but this is the beauty of Forecaster Calculator, is that it is simple to use. The calculator also contains a range of smart defaults to get you started in the back, which reflect standard silviculture regimes for Pinus radiata and Douglas fir. Again, I will show these in the demo later on. And there are potential for add-ons in future versions. Additionally, the updates and version upgrades no longer need to be manually distributed. For example, when the expert Forecaster version is updated with perhaps a new surface layer, then this will be directly transferred to the calculator in the back end. So let's take a look at the calculator for a quick fly through.
Firstly, you'll need to visit the FGR website. Once there, navigate across to the Calculators button and click. In the drop-down menu, you'll see Forecaster Calculator. Select that. You're taken to a calculator link page, which holds the Forecaster Calculator link and some further information. Before we move into getting started on a simulation, I just want to notify you all that if you are a first-time user, you will need to register. Simply fill in the field, noting that the asterisk fields are compulsory. Once you've finished the registration process, an email will be sent to you to complete the process with you. Then you can complete to log in. Now, if you have forgotten your password at any time when you're returning later on for another session, and you forget your password, simply select the forget password button or link and enter in your email address. And once you've submitted that by selecting the button here, an email will be sent through to you with further instructions on resetting your password. Let's go and log in. Okay, you'll notice that your email address will be put up in the top bar here. A couple of things to note before we move into actually running a simulation. The About Us page. This About Us page has a lot more information around the site selection, model selection. This accordion structure will open up if you select it. For example, the cutting strategies. So currently in the cutting strategy we have at the moment within Forecasted Calculator is the domestic cutting strategy. Just a note for you all that we are looking at incorporating export cutting strategy into the tool, but for now it's just focused on the domestic cutting strategy. And I'll talk more about that when we go to simulate. The other thing I want to raise with you here as well is that if you get stuck at any point, you're more than welcome to reach out to Integral. They, as I've said in previous slides, they provide the support and the help desk for any of your requirements in that space. So if you get stuck, please email them. And if they get stuck, they will reach out to myself or to another at Sawn to help with any queries that you may have. Okay, let's get started. So we'll go back to home and we just get started. Now what you'll see here is you'll see a map. It is a big map and at the moment it's in the road view. So what I'm going to do is I'm going to change it to the aerial view because I quite like that view more than the road. I like to see some of the greenery, and you can actually go to your woodlot. So if you're actually living nearby your woodlot, you can actually toggle there using this radio button, so you can go to your current location by selecting that. There's a little bit of a delay here we go, and then you can also zoom in. So I'm going to zoom in here to my current. I'm just going to try to realign that a bit there, and you can actually zoom out as well. The other thing that I'm going to do is I'm going to take us to a different location to find the woodlot that I'm wanting to use for this demonstration, which is this location here, which is the Puraki Forest, which is a sawn experimental forest. And if you've been attending the conference, you may or may not have heard yet from Loretta Garrett. She's going to be presenting the Puraki Forest in another talk. Anyway, I'm going to use this forest here for the demo today. On the other side here, if you do know your latitude, longitude and other information, you're more than welcome to populate that in these fields here. I just want to also make note that the 500 index, if you are wanting to run a simulation for the Douglas fir regime, you'll need to have that number, or you'll need to know the 500 index for your area. That's a manual process, and there's reasons for that, and you can find that in the About Us page. I won't talk about that in the essence of time. So yeah, for this one I'm going to drop a pink pin onto the Puraki of that woodlot. It may be over here, and you'll notice that when I move this pink pin, this information here changes and updates as well. So the next thing is just if I want to simulate a regime, we've got these input values here. Look, these are the conditions, this is the event. I've already been in here. Now that's the other thing, I just want to note that your last session under your login will remain in place. So you don't have to keep recreating it. If you did plant your woodlot in 1996, then it'll keep it there. But if I want to just change the regime to, say for it's a Douglas fir, then I will go into these defaults. Remember I mentioned there's a set of defaults, so it actually comes up with an initial default. So I'm going to select, I could select Douglas fir, this is the initial default settings already put in place for you, which you can modify. But I'm going to go back to the Pinus radiata because this is in Pinus radiata, so I'm going to keep it that. And this is what I'm showing you here, is that this is the actual default. I'm going to change this back to 1996 because I just want to change it to 1996. And please, Narita and Co, if you're watching this, I am just making this up. I'm not going to follow the regime, unfortunately, at this stage. But what I am going to do, just for the essence of this demo, is just make some updated changes. I'm going to look at changing, there's a prune event. So the first one I changed is plant event, and then there's a prune event. I'm going to change it to 500 stems pruned. I'm going to, and there's a thinning event, so you can add those. So I'll just show you how you can do that. You can add an event just by these, there's a plus or a cross, so you can add an event. So you just select the condition, and whether it's an age or maybe it was a date, a particular date, a bit like the planting date, and you can do that, and you can put that in years. You can change that. You can add a thinning event, a measurement event. And the measurement event is around the stockings, the basal area, and mean top height, if those are the measurements that you took at that time. But for the essence of this, I'm not going to add that in. I'm just going to, and you can delete events as well. So you can customize it to those particular events. And then I'm just going to simulate that. So just recap, so you can add on the condition, so it's whether it's a date, an age, a DOS, or it's in a particular event, so planting, pruning, or thinning. And there's also, I just want to point out here before we simulate, I might change the age of the clear fowl, so there's a clear fowl age, and I also want to point out that in the clear fowl field, you can look at the cutting strategy, and if you know the prices, see it's a domestic cutting strategy, if you know the current prices, you can update those, so price per cube. So you can actually update those prices in accordance to the current pricing, which will help to bring that accuracy a little bit more on your reports. Keeping in mind that this is just for quick idea or estimate, and again, if once you've got that and you want to seek further advice, I'd highly recommend that you seek a consulting firm to further do that analysis. This is just a quick calculation. Okay, so I've put all of my updated my events and conditions. I've got my location. I'm going to simulate that now, and it's just going to churn away, working through the various models in the back, and it's going to bring up these 4 reports as I described in the earlier slides. So the log yield report, which is a downloadable PDF. I have been in discussions, we may look at making these in a different format for you, in terms of not just a PDF. So this here, log yield report, again, looks at your total recoverable volume, the cutting waste, and the total standing volume. So, so there's that report. There's also the annual crop condition, which goes through and it marks the events, so all the events that have happened and the impacts on your crop as it's growing through time. So, you know, you'll see there's a planting event and then there was a thinning event. So this, again, if you need to know more information about these outputs, go and seek consulting advice. Okay. And then we've got the last 2 reports, so just your silviculture details again. Just talking about there's your pruning events and the dates, the times that they happened, and so on. And the last one is the annual crop condition, which is there's more detail around what has been happening in those measurement events and things like that. So, okay, so that is a simulation. Again, if you need any support or any help on if there's some errors or anything that pops up, please contact Integral and again seek consulting advice.
So the take-home points for today are that it is accessible anytime, anywhere. It is device independent. It is consistent with the expert version of Forecaster and the latest available version. There's potential for add-on features in future versions. We've tried to keep it as simple as we can to ensure that it is easy to pick up and use. It is for small woodlot owners and small forest owners, and we encourage those owners to log in, have a play, and again seek that consulting advice if you are near that time to harvest. And we welcome any feedback you may have on the calculator itself. We are in the process of updating the calculator functionality to include additional features. Please submit your feedback to Integral, and the details are found on the Contact Us page of the calculator site. And you're also more than welcome to send your feedback via my details here. So that sort of concludes the presentation. Thank you for listening, and thank you for inviting me to speak today. And I look forward to hearing from you all in terms of your feedback going forward. So thank you once again. Bye-bye.
Hi, I'm Toby Stovall from Sawn, and today I'll be doing a short update on cypresses within the FGR SWP program. Within the program, we're working on 3 species: Cypress lusitanica, macrocarpa, and hybrids between those and a few others. Lusitanica breeding trials began in 1984. We had a second generation trial series fail in 1998, a combination of goats and a very low fertility site. So in 2006, we repeated the second generation, which led to a third generation of trials going in recently in 2017. Along the way, we ran a clonal program for lusitanica because cypresses are very amenable to propagation via cuttings. Currently, the clonal program for lusitanica is parked. We're not investing in it. And from every generation, the new selections have been grafted to the seed orchards, and good quality seed orchard seed is available. Macrocarpa, similar story. Trials started in 1984 and the second generation in 1999. We also, similar to lusitanica, went down the clonal route and identified some good clones, but that's currently parked. Along the way, interest in the species declined as canker spread around the country. But what we did notice in some of our trials was we had some tolerant parents. And in 2010 and 2011, we went to the trials and selected trees that didn't appear to have canker. That was at Guavas and the Long Mile and Birch Hills. And those selections were grafted to the orchard at Proseed, and we waited till they were producing seed, and in the meantime Proseed was doing some controlled pollination. So in 2018 there was funding made available to plant this material out, so we got 3 new progeny trials in 2019. We'll be monitoring those for canker infection. We really want to find tolerant families for future deployment and increase grower confidence in planting macrocarpa again. Cypress hybrids. Our breeding plan calls for hybrid swarms, which is basically crossing everything with everything. Our main interest hybrid, however, is Eucalyptus, which is yellow cedar, which has the potential to add durability to the hybrid. We were lucky enough to have pollen supplied from British Columbia from their breeding program through a collaboration with John Russell. We also used Arizonica and Guadalupensis, which are more canker tolerant. And we crossed these to our best Lusitanica and macrocarpa from our clonal and progeny trials. And evaluation trials were established in 2009, 2014, 2015, and 2017. To date, we've evaluated 130 hybrids. 30 from the first round were identified as being good propagators. They were easy to root. And from within those 30, we released to the market 6 new Avenzii types and 6 new Leyland types. And we've been establishing those lastly into 2019 at sites to look at site species mapping. Is there any G by E happening? So we have 8 sites in total planted now. We have 150 additional genotypes, hybrids, yet to be evaluated. And we are getting input from the Farm Forestry Association through their Cypress development group on what they think is ideal types. So the future of cypresses, we really want to identify canker tolerant macrocarpa and rogue the orchard. This will increase confidence to plant more macrocarpa. We'll maintain the Lusitanica breeding program, which is based on growth and form and monitoring canker. Heartwood and durability of the best growing hybrids is going to be very important. We see hybrids playing a big role going forward in the cypress space, and we want to confirm that we've added durability by using Eucalyptus as a parent. And if people are interested, the new released hybrids are available now from a number of nurseries. Thank you very much.
Hello, Paul Millen's my name. I'm a Director of Vineyard Timbers Limited and the New Zealand Dryland Forests Initiative Project Manager. Today I'll be talking to you about the New Zealand Dryland Forest Research and Development Program. Here's an outline of what I will be covering. We'll be looking at the startup of the NZDFI, market opportunities for naturally durable hardwood, provide an overview of our research and development program, as well as look at our Eucalypt species, yes, their adaptability, natural durability, and the regimes we see for growing them. We'll also cover briefly the branding of our improved planting stock. Post-breakage in Mulberry Vineyards started our local research with 5% breakage per annum due to mechanical harvesting and pruning. That with currently about 300,000 hectares of vineyard with 600 posts per annum, there's 900,000 posts needing replacement. You can see in these photos the broken posts and the piles of posts that can accumulate in some vineyards. With this already happening in 2003, we saw the opportunity for producing a naturally durable timber post, and both started planting Eucalypt trials then, as well as processing trials, getting some local trees sawn from good hardwood, durable species, and being able to sell posts to local vineyards who liked the high strength, the natural residues, the natural durability, and the potential for zero waste that these posts offered. We saw other markets for durable hardwood beyond the vineyard posts. There's those in the infrastructure networks throughout New Zealand that we have a lot of use of hardwood, as well as there's potential for the high strength these species have to be converted into LVL beams. And more traditional home decking and outdoor furniture is in significant demand, and there's significant export potential to replace tropical hardwoods with certified timber. A quick look at a comparison of the export sawn timber value to the import sawn timber values in New Zealand at port shows that there is an opportunity, that this is a 5-year average unit value difference of imported timber over exported radiata of 800 to 900 per sawn cubic metre. In 2008, the NZDFI was established by the 4 partners: Proceed New Zealand, University of Canterbury School of Forestry, Marlborough Research Centre and Vineyard Timbers. The goal of successful durable eucalypt plantations, there's been 4 strands of to our research around free breeding and propagation, around wood technology and heartwood, site characterisation and growth and yield modelling, and plant protection and risk management, all necessary for successful eucalypt forestry. One of the key things is understanding the 2 climate drivers that define the adaptability of eucalypts in New Zealand. These are rainfall, which is shown in this map, and the zones where we have drier parts of New Zealand are where we have our breeding program. But even in the higher rainfall areas of New Zealand, we are discovering many of our species grow. So the more limiting factors, the minimum winter temperatures, because of the impact of frost on young plantings. This map shows that the North Island is considerably warmer than the South Island by 2 to 4 degrees largely, while Northland is in fact 4 to 6 degrees even warmer than the rest of the North Island. So we're focused on that central North Island part of New Zealand, and by that the areas in yellow and green, and then the northern parts and coastal areas of the South Island. However, climate change is warming things up, and that could see being able to grow eucalypts even more widely in the South Island. The NZDFI species we've selected for breeding include Eucalyptus persistuana, globoidea and quadrangulata as our primary species. There are 4 secondary species: Argifloea, Cladocalyx, Macarinca and Tricarpa. Now, all of these species are run through our breeding program with a focus on fast growth and straight stems, high natural durability, early heartwood formation and colour, drought and frost tolerance, pest tolerance. They all coppice vigorously, which is one of the selection criteria for them as species, and they've also got nectar and pollen for native biodiversity and beekeeping. Here's a slide showing our breeding population as it stands today across various sites, and then the map shows in red, the red dots are all of the trial sites that we have throughout the North Island and the northern South Island. You can see a particular focus on Marlborough. This table you can spend some time looking at more closely, but it shows the key wood properties of density and stiffness, and that by and large these are double the density and stiffness of radiata. Natural durability is our key wood property of interest, and it's classified on the expected life performance of wood in either indoor or exposed to the weather situations. The durability is defined as the inherent resistance of a species specific timber to decay and to insect attack, and it's through the use of natural durability classes that this is shown, as in this table, where based on the Australian standard 5604 is 1, 2, 3 and 4 classes with their in-ground and above ground life expectancy shown. So the class 1 timbers are those that are the best timbers. The natural durability ratings for the NZDFI species are shown in this table. I won't go through them in detail, but they are either class 1 or class 2 species. Briefly on eucalypt regimes, we've seen an opportunity for a novel regime growing 15 to 20 years posts or peeler pole plantations that will supply posts and poles for vineyards and horticulture, and or logs that can be rotary peeled for LVL, and we're looking at the potential to harvest upper crown and foliage for bioenergy and eucalypt oil. Traditionally, eucalypts are grown for large saw logs under 30 to 40 year rotations, so we can see that being done with our species. Also that they can be planted for permanent forests due, again, this time their high density and fast growth rates lead to rapid carbon sequestration, and the coppicing ability will help soil stabilisation and nectar and honey for beekeeping and biodiversity is another benefit they could offer. Continuous cover forests are an opportunity where a plantation can be selectively harvested once it reaches about age 20, and smaller saw logs can be taken and or post and peeler poles. So there's an opportunity for any grower. We have a branding program for our improved Eucalypt seed and germplasm and the nursery stock that will be produced. This is the Xylogene Nature's Green Diamond brand, and royalties will be collected on the sale of Xylogene seed and plants. We see the brand could add value to future hardwood forests and timber products by the formation of a cooperative or another legal entity of Xylogene forest growers and processors that produce Xylogene hardwood products. And there's the vision for the future shown in this poster. It captures much of what I've said and shows in a chart the planting starting from 2020, in the middle there, the aim that we produce our Xylogene branded hardwood chain. If we're able to do that, we think New Zealand will be in a strong position to be a unique producer of certified durable hardwood. Thanks to an excellent dedicated team of people must be given for making all of our work program possible. They are all listed here, and in addition there's the many supporters of the DFI over the last 11 years. Thank you for listening.
Hello, my name is Toby Stovall from Sawn. I'll be presenting a short update on industrial eucalypts for the FGR workshops. The program currently cover 3 species: this regnans, fastigata and nitens. Historically, we've focused on these for fibre, but there's some interest in solid wood products. Eucalyptus regnans, the breeding program started in 1978. The breeding population size is currently around 100 families. We're currently in the 3rd generation. The last round of tests was planted 2009, 2010. We have done a growth and form assessment, and new selections have been made and grafted to seed orchards. We've also established gene resource plantations of the species at 2 sites, and we're going to convert one of the trial sites to a seed stand in 2020. The gene resource stands and the progeny trial conversion is just to allow for more seed production if there's more demand than the seed orchards can supply. Fastigata, very similar, started in 1978. However, this population is a bit larger, it's around 200. So we've employed a rolling front strategy where we split the breeding population into 2, which enables us to spread the resource requirements. The first half, which was 2 trials, have been assessed for growth, form and stiffness. The second half, another 2 trials, has just been assessed, and we're due to report on our findings, and we will identify new orchard candidates if people want to graft into orchards. And similar to regnans, we're converting one of the trial sites to a seed stand, just in case there's more demand than the seed orchards can cope with. Moving on to nightends. Breeding started in 1978. Population size here is similar to fastigata. It's around 220, using a rolling front strategy where the population is split into 2. Currently, from the most recent trials, we did a significant wood property study in the second half of the population, which involved felling 780 trees, which were intensively studied for growth strain and shrinkage, stiffness and checking. And we also collected DNA to start genomic studies in the species. New seed orchard selections have been made from this generation. It's the 4th generation for the species. And further work in the near future is to use the sawn dispot to scan some samples from the felled trees and create an NIR model to predict some of these traits so that the future research can be done with non-destructive sampling. The genomics results, we had 700 trees from a couple of sources within the trial, done in collaboration on this Eucalypt 60K. Genomic data tended to improve prediction accuracy. So if you look at the chart, you can see the black towers, which are the pedigree or the phenotype-based information, and the grey towers, which is the combination of marker-based information and pedigree, and all of the towers increase in size and prediction accuracy for all of those traits: diameter, growth stress, tangential shrinkage, and wood density. One of the limitations of growing nightends is attack by Cupressus beetle. Spraying is possible, but it's becoming more and more regulated. So we initiated a Cupressus browsing trial with the cooperation of Southwood Export Limited. Sawn collected adult Cupressus beetles, around 2,500 from Poranui Station at Taupo. And they were segregated into 4 pairs per container and shipped to a progeny trial at Howden's Forest. And the Southwood Export staff released 2 pottles per plot in 2018. And the reason we had to import the Cupressus beetles is at that site we'd been waiting for Cupressus, but the levels were very low. So we monitored the trial monthly after release, and around April, May, the decision was made that we had seen enough chewing, that an assessment was a go. So we used a palatability score, which ranged from 1 to 10. 1 was no chewing and 10 was completely stripped, like a witch's broom. Analysis of the data we got gave a heritability of 0.15, which is similar to diameter for a lot of species, so scope there. There were some differences between the orchards and sources which made up that trial. If you look at the graph to the right, the grey area contains families that are above average for growth but below average for chewing, so there's potential in this population to select for browsing tolerance. And the trial won't be sprayed this summer, so potentially we'll get continued chewing and our second assessment could go ahead and we'll be able to confirm these findings. Some examples of the gains from the program. Regnans, we're in the third generation, we've improved DBH by 31%. Vastigata, we're second to third generation, we've made 15% gains in form and diameter. The form gains come from a reduction in forking, which Vastigata is prone to. Night hens, we're in the fourth generation, we've made gains, 30% reduction in internal checking. We increased volume and density in the last round, which is unusual because they normally go against each other. The take-home message, we've got 3 species here that are well tested and understood. There are high genetic quality seed available from seed orchards, from ProSeed and Southwood Export. Work continues on products. There'll be other presentations on thermal modification, LVO, and possibly CLT. There's ongoing research into pest control, that's Cupressus and EVB, and that's in collaboration with the University of Canterbury. And future research post SWP in the next 3 to 4 years will focus on wood quality and products, because the breeding is pretty well under control. And that's me. Thank you very much.
My name's Simon Rapley. I'm going to give an update on redwood genetics in New Zealand. There are now more than 10,000 hectares of redwood forest in New Zealand, and we know from tree sales from the nurseries that there are more and more trees going into the ground each year. People are interested in redwood because it's a high value timber. Redwood has other traits such as the ability to control erosion better than almost any other tree on steep hill country. And redwood is very well suited to uneven aged management. We also have government policy now encouraging greater diversity in the forestry sector. And redwood is recognised as a viable commercial forestry crop in New Zealand. I am a registered forester with New Zealand Institute of Forestry. I have been growing redwood for a living since 2006, and as a hobbyist, just looking at the photograph there, I started working with redwood back in 1999 on some family land. My current role is the Managing Director of the New Zealand Redwood Company. Interesting for us to look at the situation in California, where which is the natural range of redwood. Foresters there have been considering redwood silviculture for a lot longer than what we have here, and have come up with clear strategies. And also for New Zealand foresters and researchers, there are some important differences with redwood silviculture than most of what we do here in New Zealand. And firstly, redwood cutovers don't require replanting. Redwood stumps coppice sometime after harvest. There's a small percentage that don't, but most of them do. And the next crop grows very rapidly off an established root system. And the photograph on the right shows a cluster of stump sprouts that would be 50 to 60 years old, or 50 to 60 years following harvest. Inside that little ring of sprouts will be an old rotting stump from the original old growth tree. And the commercial cut in California is based on these regenerating sprouts now. There's virtually no old growth harvest anymore. The Californian foresters do plant redwood, of course. Redwood occurs in mixes with various other trees, and following harvest, they like to put all of the land back into redwood on account of its high value and ease of management. Traditionally, they've used seedlings for this interplanting, but for a number of reasons, including unreliable cone production and low germination of the seed, there's been a shift to clonal propagation. The last good seed crop was 2009, following wildfires, and the foresters are hoping that there'll be some good seed production next year following the fires that they have in California at the moment. Redwood flowers in the winter, and although California may get us a similar rainfall to New Zealand, none of it falls in the summer, it all falls in the winter. So their winters are cold and wet and just not good conditions for pollination of the flowers. Another reason that's driven the shift to clonal propagation is that redwood is one of the few conifers that can, where mature trees can be cloned. And of course, that gives the opportunity for rapid deployment of improved genetics. Breeding programs aren't necessary where desirable parents are crossed and seed with its inherent variability is produced. Mature trees with the desirable traits are identified in the forest, and they are cloned, and tissue culture labs can literally produce hundreds of plants in a relatively short period of time. The California growers have recently formed a tree improvement co-op. There are 20 members, and that is pretty much all of the redwood growers in California. They have engaged the services of Dr. Keith J. Wickrama, and if that name seems familiar to you, maybe it is. Keith was with the NZDFI for a while. The co-op has almost 200 genotypes under evaluation, and all of its members are actively bringing material into it for evaluation. It is worth mentioning at this point that they do have different selection criteria to New Zealand. To a Californian redwood forester, all redwood is good redwood in terms of timber quality, and they have no interest in selecting for wood properties. The New Zealand situation is that we have 6 suppliers of redwood planting stock. 4 of them are forestry nurseries, and they are some of the mainstream nurseries. We also have 2 forest management companies who both have an interest in genetics and access to improved genetics, and they're contracting nurseries to grow redwood planting stock for their own planting programs and for sale. These 6 suppliers have production in the range of 10,000 to 250,000 trees each year. All of the nurseries are using seed to some extent, and after contacting these nurseries recently, I was pleased to find out that none are using New Zealand-based seed anymore. There are well-described problems with New Zealand-derived seed, and probably the best example is seed from the Memorial Grove in Rotorua, which is a stand of magnificent redwood, but we believe that most of the trees are brothers and sisters or closely related. Possibly the original seed came from a single tree that was felled for cone collection. But anyway, although those trees are good examples of redwood, their offspring have problems with inbreeding and are less vigorous, and there's a belief that there are compromises to wood properties as well. The largest supplier of redwood clonal stock is producing containerized trees derived from tissue culture. The little flask in the photograph is redwood tissue culture trees as they've been transferred from a lab where they're multiplied up to the nursery, which grows them on to a plantable size. The selection criteria are growth and form. I mentioned before that the Californian foresters are not interested in wood properties, but the New Zealand growers think that with the ability to clone redwoods and bring them into production rapidly, that all traits of interest should be considered in the selection process. And the second trait of interest to the New Zealand foresters, which is of no interest to those in California, is epicormic sprout growth. We prune out redwoods in New Zealand. Virtually everyone who's planted redwood is intending to prune them, whereas in California they don't. They have very little in the way of management inputs, and so they don't see any problem with epicormic sprout production. Now, the largest supplier of tree redwood planting stock in New Zealand is actually a member of the California Redwood Tree Improvement Program and has access to genetics from that program. And because of the interest in wood properties and epicormic sprout production in New Zealand, the elite trees from the Tree Improvement Cooperative are evaluated in New Zealand for those. The foresters in California, as a recognition to what we're doing in New Zealand, collect wood samples from the parent trees, which are shipped down to New Zealand for testing. And unfortunately, with epicormic sprout production, we have to wait till the trees are pruning age in New Zealand before we can evaluate them for epicormic sprouting. There is really has been no attempt at redwood breeding as we think of breeding. The focus is on clonal forestry, which has some important differences. We simply go into the forest, pick out trees that are bigger than their peers. We can take increment cores and have the heartwood tested for natural durability, basic density, any of those things. We have one supplier of redwood planting stock who has established seed orchards in New Zealand, but they are not yet in production. And we have ProSeed have been working with redwood and attempting unsuccessfully, unfortunately at this stage, controlled pollination. So there is that is a good strategic approach for tree improvement in New Zealand, is crossing parents with desirable traits and then creating a New Zealand landrace from those. But so far that's fairly early stages, and again the reliance is on clonal production. And this is the final slide, and it just illustrates the issue of epicormic sprout production. The tree on the left is just a random seedling that was pruned as part of a trial a number of years ago. It does still have a few branches on it, but you'll see that there are a whole lot of small branches and epicormic sprouts that have to be removed if a forester wants to produce clearwood in that butt log. And with redwood, they will grow back. Following pruning, some trees that we describe as hairy will, even if you clean them up like the stem on the right, the next time you see that tree, it will have sprouts up and down the stem. Now, the cost of pruning that tree could be as much as twice the tree on the right. And if, when the pruners come back in to do the second lift, they have to take off a whole lot of sprouts again before they do the second lift, then you can see that it wouldn't take much to double the cost of pruning operations. So we are very interested in this trait in New Zealand, and as I previously said, all of the growers in New Zealand are pruning their redwoods. So that concludes my presentation. Thank you for listening.
Good afternoon. Thank you to the organisers for this opportunity to talk to you about what's current in poplar breeding in New Zealand. My name is Ian McIver. I work for Plant and Food Research based in Palmerston North and have been involved with poplar breeding since 2001. The poplar breeding program started in Palmerston North under the leadership of Chris van Kraenoord back in the 1960s, and it was within the activities of the then Ministry of Works, with a focus on breeding poplars for New Zealand conditions and purposes, particularly around soil stabilisation. So we create new varieties to meet various needs. I've already emphasised soil stabilisation, particularly on farmland, but also for shelter belts, for shade, carbon credits, pest and disease resistance, drought fodder, aesthetics, wood products. And of course, we want to bring more genetic diversity into New Zealand's population. 90% of New Zealand poplars being planted currently are just 3 clones. We breed with the pure species or hybrid material we have in New Zealand from earlier imports. You can see the graph shows you where the majority of those imports were made back in the 1970s. Budget constraints are the primary barrier to importing seedlots or hybrid material. However, since 2000, we have sent New Zealand bred clonal material to a number of other countries, and we network with other member countries of the International Poplar Commission. So importation of seeds and clonal material has not been totally discounted in future. A number of poplar clones are marketed commercially. They cater for a range of climates and uses. Information on these are on the website poplarandwillow.co.nz. We have a number of novel or new hybrid poplars in trials at the moment. You can see there are 6, 12 and 16 different poplar clones. The wide space trials are on sloped farmland in different regions and in different climates. Spacings are 10 metres by 10 metres generally. Shelter belt trials are on pastoral or horticultural land. Spacings are 2 metres and 4 metres. Our pruned trial trees, of course, provide useful fodder for the stock on the farm. Related hybrids, i.e. the same species parents to ones that we are evaluating here, are grown for timber and wood products internationally. Poplar wood industries operate in many countries of the world, both in the Americas, in Asia, and in Europe. And of course, there are opportunities for poplar wood use in New Zealand. These photos show a number of applications with battens, gates and timber, all milled from trees originally grown for soil stabilisation. Close planted trials, often Van Nelder pattern, are used to assess timber potential of poplars at a range of densities. The example given here for 18-year-old Kawa poplar shows that TBHs are close to 50 centimetres for medium densities at this age. We have 16 poplar clones in a poplar demonstration trial on State Highway 1 south of Taihape. This is an opportunity to readily compare them, their form and their growth rate. The demonstration is unique in New Zealand. It will become an important resource in future. One of the risks, of course, and this is true for a lot of our on-farm trials, is that they're on private land. And if that land is sold, the new owner may not be as sympathetic to hosting a trial as the current owner. Well, that brings me to the end of this short presentation. Thank you.